And good day on ramps. We're going to look into Unit 9.1.2. Okay. And we're going to delve into the study of a rational function. Okay. So, what I recommend is that you have pre read this section to the exercise portion. And I'm going to walk you through this. So just to make sure you have a good understanding of this, okay? So it defines a rational function. A rational function is a function of the form where you have this function h, okay? And it's made of the ratio of two functions, one f and one g, okay? So as examples, I mean, it can be as simple or as complex as you want. F of x could just be x, right? And g of x could be x squared minus 5 or something, right? Let me fix that, okay? And it's called rational because, remember, rational numbers, look at the analogy here, okay? Rational numbers, and let's get rid of this. Let me rewrite this, okay? You don't have to write this down. It's just kind of pre-thought, okay? So you have two functions, right? That's a rational function. You have f of x equals x and g of x equals x squared plus 2x plus 1. What about rational numbers? Remember, they were defined as the ratio of two integers, okay, such that b does not equal 0. And you're going to have the same restriction, okay? You cannot have values of x such that this function is equal to 0 because you can't divide by 0. That's not real, okay? So, because of this consequence, you end up with these asymptotes. Okay, so then they defined asymptote, and that is an asymptote is a line that such that the distance between the graph of a point P and the curve on the line approaches 0 as the distance from point P to the origin increases without bounds. So, what does this look like? Well, you have a graph. Oh yeah. Okay, I'm trying to hold the XP pin on the table. Let me see if I can do better holding it like I normally do. It's a little better, right? Okay, so if I'm approaching the x-axis asymptotically, okay, that means as x increases, the distance of the curve approaches the x-axis, right? But you can, you know, the number line can be infinitely expanded, okay? So if I take this section here and zoom in on it, okay, then it's still going to look like this. And it's still getting closer. There's always going to be some gap in between here, however infinitesimal it may be. Now, in the real world, sometimes, it's effectively 0, but it never really is 0 because there's always some difference between this line, it's non-zero, and the x-axis, which represents f of x equals 0, right? And you can have infinite number of decimals, right? Like 0.01, that's close to 0, but it's not 0, 0.00001. That's even closer to 0, but it's not, okay? But effectively, it could be 0 because, like, for example, if you have 1 penny, technically speaking, you have something, but it's not much. So effectively, you could say, well, I'm still broke. I have 1 penny, but what can I buy, right? But it is non-zero, okay? So asymptote is a line that would, in this case, be the x-axis that the graph is approaching, okay? So it's a pretty simple concept, but I don't want to assume that you've got that, okay? And you've seen this when we did the rational functions. Well, I'm calling them rational functions now. The inverse variations, right? So y equals k over x. And you saw that that graph, let me make sure you can see this, okay? Y equals k over x, that graph looked like that, right? Because you can never get 0 by dividing a number. So it's going to approach the x-axis asymptotically. It's never going to be 0 though, because you can't get 0 by division. And x cannot be 0, so it's never going to be touching the y-axis. It's just going to get bigger and bigger and bigger without bound. Okay, so that was your first simple rational function. Okay, all right. So what now? So now they're going to confine the study, which means at this time, we'll look into it later, okay, to that of vertical or horizontal asymptotes, okay? So vertical asymptote, that's going to be one that goes like the y-axis. That's vertical, right? That's the line x equals c. The y-axis is x equals 0, but that could shift left or right. Hmm? Uh, for a horizontal asymptote, that would be like the x-axis. And I'm assuming you can see that on camera pretty much. Uh, that's horizontal, okay? Well, I'm not sure why that was flickering. Maybe back to here. Okay, there you go. Now, notice the horizontal asymptote inherent to, oh, well, I'm jumping a little bit. So this function here, okay, I forgot to mention that, is the exponential function, okay? And this is a growth function because b is greater than 1. They're either growth or decay. Okay, what's the best way to serve line meat? That was one of them. Dr. Frug. That was another one from Algebra 1 kids. And in Dr. Frug, they were all growth functions, okay, because the bacteria was growing, okay? So that's where b is greater than 1. Now, if you obviously look at this, in an exponential function, if b is equal to 1, well, that's always 1, because no matter what the exponent is, 1 to any power is still 1, okay? So that's why it's either got to be greater than 1 or less than 1. So even 1.01, right, if you square it, it's going to be bigger than 1.01 to the first, okay? And 0.99, if you square it, will be less than 0.99. So if a number is greater than 1, it grows when you raise it to a power. If a number is less than 1, it's going to get smaller, okay? So and notice that when x is positive, you are multiplying it by this. You have a positive exponent, right? When x is negative, you're not multiplying it now repeatedly. You're dividing, and that's why it gets smaller. Okay. Now, when x is 0, then you are not multiplying, and that's why it's just 1. Okay. So now, notice that there is a horizontal asymptote. As x approaches negative infinity, that direction, the graph of f of x equals b of x approaches the line y equals 0, which is the x-axis, but never actually touches the line. Okay, so the next exercise provides you with a chance to think about a few rational functions, some of which you have seen previously. So let's go to the next exercise, and here we are, exercise 9.1.2. This is pretty easy, kids, okay? And in class, we did this on the TI Inspire. But if you're at home, you may not have that. You probably don't. So what do? Well, in that case, what you do is you go to desmos.com. And here we have Desmos here. Okay, so let me try to find that on my computer. And so we're going to type in the function 1 over x. So I just type in F1 of x equals 1 over x. And there you go. Okay, so now, what about the exercise? Because you have the data table, right? So in that case, what you can do is you can click on this little edit button, I think, and see how it highlights this and see where you say create a table. There you go. So now you click on create a table. When you plug in the x values, you get the f of x value there. In our table, okay, so I paused just to get that table started. And we go from -5, -2. Let me bring the cursor up there. -1. And notice as you put these points in, so just type them in there. -1 divide 2. It plots those on the graph. -1/4. I'm going to type in some more. 0. 1 divide 4. So I just type 1, the divide symbol, and then 4. Desmos is really friendly to input things. 1 divide 2 for 1/2. Okay, and then 1, and then +2, and then +5. Okay, so see how easy that is. So now it looks like you could just pretty much type, you don't have to worry about scaling your graph too much with this function. But notice that as x approaches 0 from the left, okay, y approaches -infinity. As x goes to -infinity, y approaches 0. On the other side, as x goes to +infinity, y, the function f of x, approaches 0. So the x-axis is a horizontal asymptote. But notice also the y-axis. That is also a vertical asymptote, because as x approaches 0 from the right, okay, and there's a way to notate that. I'll show you that when I get back to the notepad. Uh, this function approaches +infinity. Okay, f of x approaches +infinity. So these are more interesting functions. Okay, this is like the basic sharing function that if you have one thing and you start sharing it, you got to divide it. And the fewer times you have to divide it, the more you get per one. And if it's just one, you get one. Then you have to start subdividing it, but you can never really, you know, you can never share with 0. Okay, because then it would be an infinite number. Okay, so now uh, fill out that table for that. Okay, let me go back to the um, okay, so fill that out and graph that. And then we also have g of x equals 1 over x squared. And I've got that on this page here. And you can see g of x equals 1 over x squared. It's the same values for x. Okay, so they're using the same domain points. So we can do that as well on Desmos. And what do you do for that? Well, you just come over here, and below it, just type f2x, f2 left parentheses x equals 1 divided by x. Now, how do you get the squared? You have to use that little caret shifted 6. And then it goes up to there and you type in the square. Okay? There you have the blue line. And it's similar but different, isn't it? Wow. Okay. So now, how do you get your table? Just click on the little uh, edit list button there. And there's the table there for that one. And type those numbers in as well. -5, -2, -1, -1 over 2, -1 over 4, 0, and then just the positive ones, 1 over 4, +1 over 2, 1, 2, and 5. Okay, so now you have everything for that. And by the way, those graphs, once you have that graphed and you can fill in the table, fill that in. You should go back to the worksheet. On the worksheet here. So since these graphs and tables are in the book for this exercise, go ahead and take a picture of this when you have that done. Okay. So then what? Is this all going to be in the notebook? No, because there's more, and so you have to do some on a separate sheet of paper. Okay, sorry. Um, for example, when you get to the next page, and you get to problem 2, it says explain the end behavior of the graph of each function. Okay, so here, write down your paper. Okay, and the end behavior is 1, or wait a second, this is 2 now, right? So as x approaches positive infinity, what happens to f of x, right? Does it approach infinity or does it approach 0? As x approaches negative infinity, okay, what does f of x approach? Okay, and that's talking about in behavior. Okay, we're not talking about as x approaches 0. Okay, you could, and I guess we'll see that in a little bit. Based on the graphical symmetry, categorize each function as even, odd, or neither. So remember, an even function, that means f of negative x equals f of x. Okay, and it's symmetric about the y-axis. Okay, so think of your parent quadratic function, correct? Because let's see, that's a y-axis there, and if you have a point here, and that's x, then if this is negative x, they're both equal. Okay, they have the same y value. Okay, so f of x and f of negative x are equal. Okay, the odd function, that means that f of negative x equals the opposite value, negative f of x. And so again, if this is x and y axis, if here's x and here's f of x, then negative x, the opposite of that would be here. Okay, so think of that x cubed. Okay, poorly written one. Okay, and what makes a function no longer odd? Any vertical shift, right? So if you add a number to that, like +5, okay, well, it no longer has symmetry about the origin. Okay, it has symmetry about that point, but that's not odd. Odd is about the origin. Okay. Also, if you added any even powered x term, so if you had x cubed, and then you said, okay, well, plus x squared, that's no longer odd. It's just neither. It's neither even or odd. Okay. If you add a +1 or +2 or whatever, or -7, that's no longer even or odd. It's only odd when it has only odd power. So if you had x cubed plus x, that would still be odd. Okay. As far as the even, if you add any odd power to an even function, so x to the fourth is even, x to the fourth plus x to the third, no longer even. It's neither. Okay. However, you can add a constant at the end. Why? Because negative x doesn't affect 5. It's still going to go up and down and be symmetric about the y axis. Okay. So that's just some on that. I'm going to this is kind of scratch work here to illustrate. So let's see there. Okay. I guess those notes are good, right? So on your notebook paper, you're going to say based on graphical symmetry, categorize each function as even or odd. Okay. So you can do that. Now 4, describe the behavior of each graph around x equals 0. Okay. So now here, that's where you want to say for, let's say, f of x equals 1 over x, right? As x approaches 0 from the left. That's what that negative means. Then what happens? f of x does what? Okay, as so for each one of these, you got 2, right? So for f of x and the g of x is 1 over x squared. As x approaches 0 from the right, okay, what does f of x do? Okay, so you're going to have, you're going to put this on your paper. You're going to do 2 of these for f of x and 2 of those for g of x. Okay, and now when it comes to part 5, okay, predict and draw a graph of the following functions without creating a table or using a calculator. And I don't know if did I put that page in here? I don't think I did on here, but it's in your book. Okay. So yes, you will not scratch. You will sketch those graphs in the book on those grids that's inside the book. Okay. And take a picture of that and submit it. However, what I recommend you do is get scratch paper and think, okay, what will this look like? 1 over x to the third. Okay, and put that on your scratch paper. And then go to Desmos, okay, and take a look and say, did it match? Okay, if it matches, great, put it on the grid. If it doesn't match, well, then sketch the graph that you see on Desmos, okay, onto the to the graph, okay, inside your book, okay. Okay, so this is scratch paper here. You're testing, right? Can I predict what this graph is going to look like? Then go to Desmos. Now, if you just go straight to Desmos, then you're cheating yourself of thinking. Okay, and you may not know. You might say, I don't know, but try it on scratch paper. Okay, and then put it in Desmos, and then look at that and say, okay, I was close, not quite, or wow, I had no idea. Look at that, and then maybe think about why is it different than what you thought. Okay, good idea. All right. So think about when we looked at what happened when powers increased for odd functions. So like you had f of x equals x, and then equals x to the third, and then equals x to the fifth. And now we have 1 over x to the third, and possibly more higher powers, right? So kind of get that analogy in your mind. And you can use Desmos as a powerful tool to see that real quickly. Because, gee, imagine without a calculator or Desmos, you'd have to make a table and graph those. It would take forever and a day. We're so much more efficient with this. Okay. So now what else? Well, you've got, 1 over x to the fourth. So you've got this odd power, you got this even power. You have leading coefficient. Now, what is the coefficient of this uh, term here? Well, it's -1, right? Because it's -1 times 1 over x, right? So the leading coefficient for this, by the way, this is not a polynomial, okay? Why? Because the power of x is negative, okay? That's not permitted in polynomials. It is a rational function, right? So the leading coefficient is -1 of this, or the coefficient of this term is -1. So it's going to have like the same effect. It's going to flip it, right? Then you have -1 over x squared, and then you start having this business here. Okay, now why does it have this little tick mark? I don't know. I'm going to look that up. Okay, I'm not sure why they put that in there. Okay, and I have to ask them. I forgot to do that Friday, but it's not going to matter. Okay, because all you have to do is think, okay, what will that graph look like? You know, remember when we studied how graphs transformations that shift. Okay, when you subtract from the x, they usually cause left-right shift, right? What will happen here? Okay, and then same thing here. What will that do to the graph of 1 over x? Okay, so do that. That's pretty much the exercise, and that's pretty much this video. So do well with that. I will see you back in school. I hope this helps, and good luck with this. By the way, make sure you do the homework because a lot of times the high school quizzes, there are questions that the depth and complexity of the homework matches the quiz better than the depth and complexity of the exercises in the book. And I didn't write the book, So I wish it was not so. I wish the depth and complexity of all the exercises always matched the high school quiz. But, that's why you need to do the homework. So you make sure you're getting the full depth and complexity of what you're supposed to learn. Okay, with that, I'm going to end the video. I thank you much for your attention. And let me know if you have any questions. See what you learn about this. Okay, have a great day.